Forget tanks, warships, and spy satellites. The real arms race of the 21st century isn't happening on the battlefield. It's unfolding inside labs cold enough to freeze air solid, where machine learning and quantum physics are fusing into something the world's never seen before. Guys, hello, and welcome back to Quantumfy. In today's video, we're breaking down how Google's AI brain is turbocharging the quantum revolution. If you're not hyped yet, buckle up, because this isn't just another tech story. This could literally decide who wins the next 100 years. Let's get started. When Google gave birth to quantum's immune system. Let's rewind. 2019. Google's Sycamore chip stuns the world by solving a quantum task in 200 seconds that would have taken a classical supercomputer 10,000 years. Critics said, "Cool trick. Now do something useful." Fast forward to 2025, Willow is here. A 105-qubit superconducting beast that doesn't just flex, it stabilizes. For the first time ever, Google crossed a line theorists dream about: error correction below the surface code threshold. Meaning, add more qubits, and instead of drowning in errors, the machine heals itself faster. But this wasn't brute force. It wasn't human-written algorithms duct taping mistakes. No. Willow survives because artificial intelligence acts as its immune system. Google trained a transformer-based neural decoder to recognize the tiny hiccups and glitches qubits produce every microsecond. Instead of painstakingly checking each one by hand, the neural net predicts errors, corrects them in real time at speeds humans can't even dream of. Latency? About 60 microseconds. Reaction time? Faster than the blink of an eye. Without the neural decoder, Willow would collapse under its own quantum noise. With it, it rises as the first blueprint for scalable quantum computation. Teaching machines to fine-tune the quantum orchestra. Fixing errors is only half the battle. Preventing them in the first place, that's the art of control. In traditional labs, quantum control is like tuning an orchestra where every violin forgets its notes every second. But Google flipped the script. They trained reinforcement learning AI agents to tune the orchestra for them. These agents experiment millions of times per night, tweaking microwave pulses, adjusting entangling gates, optimizing couplers, all without human intervention. The impact? Single qubit gates became 10 times more reliable. 2-qubit entanglement gates sped up. Energy leaks, once quantum's silent killers, dropped sharply. It's like giving each qubit its personal kung fu trainer and watching them evolve into martial arts masters overnight. This pulse-level optimization isn't cute. It's foundational. Without ultra-precise control, even the smartest error decoder can't save you. With it, Willow's operations are so fast and sharp that fault tolerance becomes a real living thing, not just theory on a chalkboard. Circuits, materials, and the Tetris of quantum evolution. But wait, having good gates isn't enough. You also need smarter circuits that don't waste precious operations, and better materials so that errors don't creep in faster than you can fix them. This is where Google's secret weapon comes in: Alpha Tensor Quantum. A brainchild of DeepMind, Alpha Tensor treats circuit optimization like an epic game of Tetris, rearranging and compressing quantum operations to slash error-prone T-gate counts by 20% or more. Smaller circuits mean shorter runtimes. Shorter runtimes mean fewer errors mean fewer qubits needed. It's a domino chain, and every domino makes quantum computing cheaper, faster, and closer to commercialization. Meanwhile, DeepMind's Genome project scoured the cosmos of materials science using deep learning, discovering over 380,000 new stable crystals. Among them, tantalum-rich compounds with insane superconducting properties, exactly the kind of material that could birth next-gen qubits with longer coherence and less noise. Think about that. Google's AI isn't just fixing today's quantum chips. It's designing the atoms for tomorrow's quantum supercomputers. The quantum feedback loop, machines teaching machines. Here's where things get mind-bending. It's not a one-way street. Yes, AI trains quantum computers to survive, but now quantum computers are starting to train AI models back. In experimental setups, Google researchers use mini quantum circuits as attention modules inside classical neural networks. The circuits provide richer, weirder, more efficient data transformations, and the AI learns through them. It's a feedback loop. Machine learning improves quantum control. Quantum control creates better qubits. Better qubits make quantum processors strong enough to accelerate machine learning, which makes the machine learning even sharper. Round and round it goes. This isn't science fiction anymore. This is 2025 reality, and it means the line between classical AI and quantum AI is about to blur into something otherworldly. Quantum cloud, fault tolerance as a service. While Willow flexes its muscles inside Google's secretive labs, the company is already plotting its next move, quantum error correction as a service. Leaks suggest that Google Cloud is beta testing a system where university labs and research partners can stream their noisy quantum data directly into Google's AI-powered decoders. Imagine, instead of building a billion-dollar cryogenic facility, a small startup or university can rent Willow's immune system on demand. You run a circuit on your cheap, noisy device, Willow's neural nets correct your errors remotely, you get nearly fault-tolerant performance without owning Willow. If true, this could democratize quantum access the same way AWS democratized server farms 20 years ago. Today, quantum error correction is a billion-dollar bottleneck. Tomorrow, it could be a subscription service, pay per qubit hour. And once that gate opens, it's a game over for the old tech silos. The world's best quantum hardware will no longer be locked in vaults, it'll be an API call away. Just imagine the explosion of innovation once every grad student and startup founder can tap into Willow's immune system from their laptops. The quantum revolution isn't coming, it's already knocking. The new quantum war, winners, losers, and the race to infinity. Google isn't doing this for fun. This is an arms race just without the bombs. When Willow crossed the surface code threshold, Alphabet's stock price jumped 6% overnight. Financial analysts called it the beginning of quantum capitalism. IBM, Quantinuum, and Rigetti scrambled to defend their positions, but quietly, even the competition admits, Google's AI-powered stack is now the bar to beat. Meanwhile, national security experts are ringing alarm bells. If fault-tolerant quantum computers hit the mainstream, current encryption collapses. Bank accounts, military secrets, crypto, the entire internet, all vulnerable unless post-quantum cryptography catches up. Governments worldwide are already updating their cyber defense playbooks. The quantum Cold War is no longer hypothetical. It's here. And AI, not raw hardware power, will decide who wins. Conclusion: the future is a feedback loop. 5 years ago, Google's Sycamore declared quantum supremacy with a flashy lab trick. Today, Willow, with its AI guardians, pulse sculptors, and material architects, is carving the path towards quantum dominance. This isn't the end game, though. It's the beginning. The moment when quantum computing stopped being a maybe someday and started becoming an inevitable force reshaping science, technology, economy, even civilization itself. And at the heart of it all, not just smarter chips, not just more qubits, but machine learning, the invisible engine that's turning chaos into coherence. Willow is just the first step. The quantum AI feedback loop has begun spinning, and it's not slowing down. The only question left is, who can spin faster? And that's it, folks. If you're as pumped or panicked as we are, smash that like button, drop a comment, and can anyone catch up to Google's quantum momentum, or are we already living in the future? And don't forget to subscribe to stay quantified. Next time, we'll dive into the race for post-quantum cryptography and whether any of us are really ready. Until then, keep that curiosity high and your qubits cool. Quantify, signing off.